to another lesson, and today we'll be looking at momentum. Right? So momentum, as you learned in lower lesson, is the effect of objects in motion. Right? So we're going to look at linear momentum. So the word linear means its object velocity is only acting in one plane. Right? So if the object is moving left, it's only moving left. So moving right, it's only to the right. If it's up, only up. If it's down, only down, right? So an object will not move like cardinal point, northeast or northwest, right? So if it's moving northeast, northwest, southeast, southwest, those directions, then it's not linear. So linear just means that the velocity only remains in one plane, right? So momentum is given by P equals mv. So the m is your mass, v is your velocity, right? And the unit, therefore, mass is measured in kilograms, v is measured in meters per second, right? And also, it can be used as Newton second, right? So, because velocity, right, which you would know before, that velocity is a vector quantity. So, meaning it takes its direction in which it's moving, right? So, we use, if it's going down, it's a negative velocity. If it's going to the right, it's a positive velocity. If it's going up, positive. It's going to the left, negative, right? So what I normally use to remember this is your t for your graph, right? So you have your y and your x. When you're plotting a graph, on the right side, this is 0. On your right side, anything that's going this way, it's always a positive number. Anything that's going this way is a negative. Anything going up is positive. Anything going down is negative. So the same principle here will apply to the direction in which the object is going, right? So once objects are moving, they'll have the tendency to actually collide with something else, right? So objects moving would collide with something else, which is collision. And we have two types of collision that do exist. First type is our elastic collision, right? So elastic collision is where both objects, or the 3 or 4 objects that are being collided to, right? When they hit each other, they bounce off, right? So imagine you throwing a ball at the wall, right? The ball is elastic, so once the ball hits the wall, it's going to actually bounce off, right? And in most, even car crashes, right? 2 cars collide, they actually separate, right? So that type of collision is known as an elastic collision. And in this collision, the energy, the kinetic energy, is always conserved. So the kinetic energy before the collision, the total that was there, is equal to the total after, right? And we're going to examine those things later. Second collision is inelastic, right? So inelastic now, since elastic was when they hit, they separate, then inelastic now, when they hit, they actually move together. So they hit and stick and move, right? So this is just like glue. So they hit and they slightly glue together and they move off with each other, right? So those are the 2 types of collisions we have. So because we have collision, there's a law that we call the conservation of momentum, right? The conservation, once we conserve something in physics, we're stating that whatever was there before is equal to whatever was there after, right? So conservation of momentum states that the momentum before a collision, right, is equal to the momentum after collision, right? There's a condition for this, that there is no external force being applied to the system, right? So if we have 2 balls, ball A and ball B, their momentum, which we add together, right? Once we add those momentum, this is before they collide. After they collide, right, we add those momentum together, those 2 momentums will be equal, right? So let's look at this. So for elastic collision, in these 2 ball cases, they're both moving to the right, right? And remember, if you're moving to the right, it's a positive velocity. So VA is positive, VB is positive, right? So we have singular momentum being added together. After collision, A still remains going to the right, so we have a positive A. velocity here, and a positive b because b is still going to the right. So that's elastic. So all elastic equations will mimic this format, right? The only thing that changes would be the sign of their velocity depending on the question, right? Inelastic, right? So we have objects moving in opposite directions now before collide, and after they collide, they stick together and move in the direction that the larger one is going, right? So let's look. So A is moving to the right, and to the right again is positive velocity, right? B is moving to the left, so we have a negative. So that's the reason why this is negative here, because velocity for VB is negative, right? So we actually subtracting this momentum from this one, right? And when we do that, that total momentum here is equal to the momentum after. So because A and B now moves collectively as one, we just add the masses and multiply by the V. That V is called by some books as the common velocity. So that V represents your common velocity that the objects will move at, right? Now, with an inelastic collision, the kinetic energy is not conserved. And why do you think that is the case? Let's take a minute. All right, so since you've thought about it, inelastic, since they hit and stick, right? There is something popular about things that hit and stick. The noise that they create is greater than if the object hit and bounce, right? So we examine because there is a loss in energy, because something has to stop, right? And because of that loss in energy, because it can be due to loss to sound, then the kinetic energy is not conserved. So whatever kinetic energy was here will not be whatever kinetic energy is there, right? So these equations only apply to when the object is moving in a linear motion, right? So we're going to all right guys, so that's it for today. So next class we'll be looking at using our knowledge that we gained today to answer some questions based on momentum. All right, so see you guys next time so we may be able to work some questions together. Bye bye.